Okay, we've got down to K6. I'm going to skip K12 for a bit because that's the one with lots of work in it, and we'll go to F-C and AC. So F-C for an MGP10. When we look up that, we've got to go to the appendix, I think. There's the F-C, timber strength and compression, Appendix H. So we'll take out this code here. There's the appendix, table H for F grades, but we're in MGP. So we are in table H 3.1, characteristic values for design MGP10, MPG12 and others. And this you recall is MGP10. So MGP10, and our column was 190 by 35. So a depth of 190 by 35, bending, tension, compression, there we go. F-C is 18 megapascals. So F-C equals 18 MPa, and we have to say that is from table H 3.1. And now the area of our column in compression. Alright, for the area of compression, we know that in a slender column it's the area around the middle which really counts more. In addition to that, when these bolt holes are filled with bolts and close fitting bolts, the force actually goes through, the bolt can carry the compression force through. So we're actually not going to take any deduction for those bolt holes. So the area for this is 190 times 35. And that's pretty easy to calculate. 190 times 35 is 6,650 square millimeters. Alright? So all we've got to do left now is the K12. Alright, there's several steps in the K12, as you guys know, so we'll put that there. K12, the first thing we have to go to is look at our row CS. If it's less than 10, then this is a short column. If it's between 10 and 20, it's a transition column. If it's bigger than 20, then it's a slender column. Now, it's pretty obvious because there's no intermediate support or bracing in this one because it's a member of a truss. It's pretty obvious that it's the minor axis which is going to govern. We will go ahead and calculate them both in turn just for completeness sake. So let's say K12 here and major axis. Okay, the first thing we need to do is to find the row C value. Row C value comes from, row C, here we go, table 3.3 gives you a conservative value, or appendix E gives you a more complex but a slightly less conservative or more accurate solution. We'll go with the conservative easy one for now. So we'll go to table 3.3. Turn up to the code, table 3.3, here we go. Material constant, PC for sawn timber columns. And there are stress grades in F, down to our grades in the MGP. And seasoned timber, the material constant is 0.96. Just checking something on the side here. Okay, so there's our value of 0.96. Now we need to look at the slenderness, and we need to say, is the slenderness, we're going to work out the S. So go down to the S3 value, and for a member which is in force, connected to both ends, there's our effective length, 2,800, and we have to look at the end conditions now. So we have to turn to the table for G13. G13 table is table 3.2. Here it is in the code here, and it talks about whether you've got flat ends, whether they're restrained in both position and direction, all the way down to, is this like a flagpole where it's completely unbraced. Now we've got in the major direction 4 bolts, and here we have one end fixed in position and direction, other end strained in position only, or above it, each end held by 2 bolts, in brackets substantially restrained, 0.75. So we could go ahead and use that. However, you have to think about what is this actually bolted to. That assumes it's bolted to something completely rigid. But this is a member of a truss, as we know, and all that will do is actually transfer moment into that connection into the next member. So the slightly safer option is to say, well, what if this is a pin-pin member? And then our G13 value equals 1. So in a truss, unless we know we're bolting it to something really solid, we're going to take 1.0. So our G13 equals 1.0, and that is table 3.2. Sorry, that was